All right, we're going to go ahead and go over our second example from our notes today. We are going to convert our equation into standard form so that we can graph it to find the focus and the directrix. So first of all, we notice we have a y squared. So when we have y squared, we know that this is going to mean that our parabola is horizontal. And that means it's going to have the standard form of y minus k squared equals 4p x minus h. So we need to rewrite our equation in this form, which means we're going to get rid of any term that does not have a y in it. So we're going to subtract 2x, we're going to subtract 18, so we get y squared plus 8y equals negative 2x minus 18. Okay, so now what we can do is complete the square to find this c terms to make this a perfect square trinomial. So we take our b value, we divide it by 2, and then we square it. So we are adding 16 to both sides of our equation. So plus 16 plus 16. And now I can rewrite this as a perfect square trinomial. Y plus 4 squared equals negative 2 minus 2. And now all I have to do is factor it so my x has a coefficient of 1. So which means I'm going to factor out a negative 2 from both of those terms. And we know negative 2, when I factor out the negative 2, will be negative 2 divided by negative 2, which is positive 1. So this is my equation in standard form. And this also tells me my vertex, h and k. Remember, h always goes next to the x, so h is negative 1, and k is negative 4. All right, so we have h and k, and now what we need to do is find our p-value, and that will help us to find the focus and the directrix. So remember, our number in front that we factored out should be equal to 4 times p. So we say 4p equals negative 2, and then we solve to get p equals 1/2. And so once we have p, we can find our focus and our directrix. So our focus, we know that it's a horizontal parabola, so it's all stacked on that horizontal axis of symmetry. So you'll notice that that movement is controlled by the x coordinate. So which means we're going to be adding and subtracting p to our x coordinate. So our focus is going to take our vertex h and k, but we are going to be adding p to that x coordinate since we are moving that horizontal movement. So now if we just substitute in what we know h is negative 1, p is negative 1/2, and k is negative 4. We get a focus of negative 1.5, comma, negative 4, or you can put 3/2. It really is up to you. I don't have a preference on that one. All right, so now we have our focus, we have p, we have h and k, so we have to find our directrix. So our directrix is going to be a vertical line. And we know that if we added p to get to our focus, we're going to subtract p to get to our directrix. And again, that horizontal movement, we start with our h coordinate, and we're going to subtract p to get that directrix value. So if we just substitute in what we know, h is negative 1 minus negative 1/2 for p. So we'll add here, and that will equal negative 1/2. So our directrix is x equals negative 1/2. So let's go ahead and graph what we have here. I know the scale is kind of not ideal for these coordinates, but we'll make it work. So our vertex is negative 1, 4. Please note that the axes are counting by 2s for their scale. We know our p-value is negative 1/2, and our directrix is negative 1/2, so I'm going to graph that directrix. Okay, now I'm going to plot my focus. So that will be 1.5, so about halfway is -1, so half of that half is about my focus. So it's very smushed there. It's okay, like I said, we'll make it work. So now I have to pick my points in order to graph this. So I know my parabola is going to be opening sideways. And so it's not going to be very easy for me to count x values on either side of my vertex because my parabola opens sideways. So what I'm actually going to do is think of my parabola and when I'm graphing it in terms of my y values. So I'm going to use that axis of symmetry just like I do when I graph my vertical parabola. I'm going to pick points on either side, but this time I'm picking y coordinates. And again, I'm picking y coordinates because my graph is actually going to be horizontal, and I'm using that axis of symmetry to my advantage. So we'll still set up our table the same way. We have x and y. I'm going to put my vertex in the middle, so -1, -4. But now instead of picking x coordinates on either side, I'm going to pick y coordinates. And remember, whenever you are substituting values into an equation to solve, you can substitute in x or y. It does not matter which one, just traditionally we substitute in the input. We're using, again, our axis of symmetry to our advantage, and that's why we're choosing our y values so we can take advantage of that axis of symmetry. So on either side of -4, we have -6, and we have -2. We also have -8 and 0. So I'm picking them the same units on either side of that value, -4. So -6, -8, and then -2 and 0. So I'm plugging in y values and then I can solve for x. So I'm just going to use this equation here. So I'm plugging in y equals 0, and I'm just going to solve for the other variable. So 0 plus 4 squared equals -2x plus 1. So that's going to be 4 squared is 16. I'm going to add 2 to both sides, and I get x equals -9. So here at y equals 0, that will give me -9. I also am going to now solve for y equals -2. So substitute in -2 for y. And I'm going to go ahead and just evaluate and solve. So when y is -2, that will give me a -3 for x. So again, I'm using that axis of symmetry to my advantage. I know this will also be the same values because I picked them on equal distances from either side of that vertex. And now when I graph it, I can still graph my x, y ordered pairs. You'll notice it's going to be a little different because we have our symmetry on our x coordinates, which makes graphing a little bit more interesting than what we're used to. So let's go ahead and start up here with -9. So -9, and we're going all the way down to -8. Then we have -3 down to -6. We have our vertex -1, 4, or I'm sorry, -1, -4. And then look, we have another x coordinate of -3. So -3 to 2, -2, and then -9, 0. So we can see and remember our work with functions, and we can tell that this is certainly not a function because it is not one-to-one. We have two x's, or I'm sorry, we have an x that's being sent to two different y values, which is why solving it and graphing it makes it a little bit different than our vertical parabola that we are used to.